Hello and welcome to another episode of Old World Domestication, and this episode will cover the domestication of Scarlet runner beans, or Phacelis coccinus. Scarlet runner bean is one of the 5 species of Phacelis domesticated in Mesoamerica, and it's the third most economically important bean within the Americas, after the common bean and the lima bean. The wild Scarlet runner bean is a perennial climbing plant found at mid-high elevations from northern Mexico to Panama. There is quite extensive genetic diversity within the species, creating 2 subspecies: the red flower subspecies and the purple flower subspecies. The cultivated form is grown within Mexico, Guatemala, Honduras, and Costa Rica, whilst in Europe it's mostly cultivated in the UK, Netherlands, Italy, and Spain. In Mexico, it's mostly cultivated as a crop suited for subsistence farming. The genetics and domestication history are very difficult without proper genetic markers. So Dr. Azalea Guerra Garcia decided to do a marker analysis of the scarlet runner bean to see what level of genetic variation is extant within a species, and here are the results. It was initially believed in 2011 to 2013 that the scarlet runner bean was domesticated twice, once in Mexico and once in Guatemala/Honduras. The modern genetics indicate that it was domesticated once on the border of Guatemala and Mexico. There's at least one genetic domestication event, although another one cannot be discarded due to the lack of information regarding these Guatemalan cultivars. Based on current genetics, the divergence between cultivated and wild specimens differ between 21,000 generations, meaning it took 21,000 generations for these 2 forms to diverge from each other. Based on current genetic evidence, the population of scarlet runner beans found in the trans-Mexican volcanic belt is likely the location of domestication and the population used to breed this domesticated form. That makes sense considering that the greatest level of genetic diversity within many other Mexican and Aztec crops is also found in this location, including teosinte and its domesticated counterpart. Indeed, it's plausible that these 2 species were domesticated around the same time period. This initial population was also imported into Spain, as this volcanic belt population is genetically very similar to what's found in Spain, indicating very little changes have happened. Plausibly, they're direct lineal descendants of the initial collected specimens from this location. The Chiapas highlands strains, however, show instances of crossbreeding with wild specimens. Various genetic evidence through genetic markers studying the wild specimens in the same location showed that interbreeding between these 2 strains have occurred quite a bit in the Chiapas region, creating new land races and strains with lineage both in the wild and domesticated forms. Another interesting factoid found within these populations was that within both the wild and domesticated populations, no evidence of genetic loss has been found in comparing the wild and domesticated forms. Although there is minor changes in genetic structure based on other genetic analyses, the genetic bottleneck seems to have not been very great. This is primarily due to the fact that, unlike common beans, the scarlet runner bean relies heavily on crossbreeding, and the species predominantly outcrossing in nature, meaning that it needs to crossbreed to function. Likewise, no evidence of deleterious traits being accumulated within populations have been found, meaning that no bad genes have been found so far within these populations. This is once again due to the fact that there's self-incompatibility within the scarlet runner beans, preventing inbreeding from happening in the first place. Even within genetically isolated, such as the strains found in the Mexican volcanic belt, there's limited deleterious traits found, and the population can function fine, even though there's no evidence of outcross between this population and the other surrounding population. The cultivated and wild strains of scarlet runner beans have far more interactions with people than even the common bean, historically speaking. This is likely due to the fact that this species is found in a much more wide array of different environments. This is because this species is adaptive to a great many different conditions. This is likely because the scarlet runner bean grows in more humid environments at cooler temperatures and at higher altitudes than the common bean. Its ability to adapt to these three climates likely allowed for the species to spread a lot faster and be interacted with much sooner by people. And that about covers everything. Thank you for watching. Thank you for watching this video. If you're watching on YouTube, please subscribe to me on BitChute for a greater variety of content, 4 videos a week. And thank you to all my subscribers on both platforms. I appreciate it.